Hello friends, now we will see rate measurer, how to deal with the problems of rate measurer. What is different from the earlier topics? We have to just differentiate with respect to t only. That is the thing. Rate measurer means with respect to time, at what time it is changing. So we have to just write the equation in the terms of the variables involved, just differentiate with respect to the t and we will get whatever unknown with the help of the known things. See in this question, a man of height 180 centimeters is moving away from a lamppost. Just draw the figure. This is a lamppost. Man is here. Lamppost light is coming from here and touching the ground here. So this is actually the length of shadow. We know this. And this is the distance the man is away from the lamppost. Whatever given things, we just write it in the figure and we try to establish a relation between the variables. So it is given the man's height is 180 centimeter and the lamppost height is 4.5 meter, that is 450 centimeter. If we are taking this in centimeter, we have to take that in centimeter as well. Otherwise, we have to take in this meter and this in meter. Okay. So we will establish a relation between this similar triangle and this. So it is coming out to be 180 divided by 450 is equal to x divided by x plus y. So this is 2 by 5 on cancellation with 9. So coming out to be 5x is equal to 2x plus 2y. So this is 3x is equal to 2y. Now we have established the relation between the variables x and y. What we have to do? Now just differentiate with respect to time. So it is going to give you 3 dx by dt is equal to 2 dy by dt. Now see, whatever is given, you put it and you will get the unknown thing. Okay. What is given here? We will see man is this. He is moving away at the rate of 1.2 meter per second. Moving away means the distance of the man from the lamppost is changing. So actually dy by dt is given and that is given 1.2 meter per second. So what is that? Dx by dt is 2 into 1.2 by 3. That is coming out to be 0.8 meter per second. And what is dx by dt? Dx by dt is x is actually the length of shadow. So dx by dt is the rate of change of length of shadow. Very simple. Once again I am telling you, establish the relation between the variables, differentiate with respect to t and you will get the unknown thing. Now see question number 2. A kite is 112 meter above the ground and 130 meter string is out. See here, kite is like this. This is the length of the string which is given here 130 meter and this is the height of the kite above the ground. It is given as 112 meter above the ground. Okay, and this is the horizontal distance of the boy from the vertical direction of the kite. So if we take this x, okay, and this is constant, this we take as y, this is constant 112, okay, dx by dt will give how horizontally the kite is moving and dy by dt will give you how the cord is laid out, how the string is laid out. So we have to just take x and y as variable because x is changing, horizontal distance is changing, the string length is changing, but the vertical height is remaining constant. It is remaining 112. So we have to establish the relation. What is that? X square plus 112 square is equal to y square. You just differentiate what it is coming out to be, 2x dx by dt. This is 0 is 2y dy by dt. So what we have to find, actually we have to find at what rate string is out. That means we are interested in that dy by dt. So what it is coming out to be, dy by dt is equal to x by y into dx by dt. Now see what is x and y. If it is 130, see at a particular moment when it is 130, this is 112, by Pythagoras theorem you just write x square is equal to 130 square minus 112 square, that will come out to be 66. So at that particular moment x is 66. So you just put it here 66, y we got 130 and dx by dt, that means how horizontally it is moving, it's given. The kite is traveling horizontally at 8 meter per second, 8 meter per second. You just simplify this thing, you will get how the string of the kite is laid out, how fast it is laid out, the rate of change of the length of the string. Okay. Now see question number 3. Water is dripping out at a steady rate of this through a tiny hole at the vertex of a conical vessel. The figure is like this. Okay, water is dripping out from here. Okay, and the vertical angle is 60 degree is given. So if we just draw the figure, this is coming out to be 30 degree, and at a particular moment we take this as R, this as H, this as L. We will just make use of the variables whatever is required in the question. Water is dripping out at this, so we are concerned with the volume. So volume of water in the filter at any moment is 1 by 3 pi r square h. Is it? Filter is this. Find the rate of decrease of slant height. So we are interested in slant height only. So we have to get the value of R and H in the terms of L. Whatever required variables value we need, we just convert the other variables in the terms of that only. See here, if complete angle is 60 degree, then it will be 30 degree. So we can write cos 30 degree by Pythagoras theorem. You know what it is coming out to be? Base by hypotenuse. So the base is here h and hypotenuse is L. So we can get the value of h. H is what? L cos 30 degree. And same way we will get R is equal to L sin 30 degree. So we can just write RH and H in the terms of L only. So it will be 1 by 3 pi r square means L square sin square 30. Sin 30 is 1 by 2. So 1 by 2 square into H. H is what here? L cos 30. So L into cos 30 is root 3 by 2. So ultimately it is coming out to be 1 by, this is going to give you 1 by 2 square is 1 by 4. So 3, 4, 12, 2. That is 24, and here root 3, here pi L cube. So very simplified version of this is like this. So we got the volume in the terms of the slant height only. Now you just differentiate with respect to t. So dv by dt is going to be root 3 pi by 24 into 3L square dl by dt. Now you see that dv by dt is given 1 cubic centimeter per second. So this is 1 is equal to, if you just cancel out, this is coming out to be root 3 pi by 8 into L square. The L at that particular moment is given when the slant height of the water in the filter is 4. So it is 4 square, that is 60 into dl by dt. So dl by dt is coming out to be 1 by 2 root 3 pi. L is what? Length. So centimeter per second. Just don't forget to write the unit centimeter per second. So you will get the rate of change of the slant height. In a nutshell, we can say we just write the equation in the terms of the variables, and if the variables are not there, we introduce the variable by appropriate modification with the geometry help. And after insertion of the required variable, we differentiate with respect to t, put the values of the known things, we will get the value of the unknown thing. Hope you are understanding rate measure very well. Okay, thank you.
For useful videos, subscribe to my channel Santosh Pembi on YouTube, or log on to my website www.mathsonphone.com. Thank you.